Hello, good morning. I'm discussing nano indentation. Okay, nano indentation is a relatively new technique to obtain mechanical properties of nanometric region. By studying the stress-strain behavior when a nano indenter is impressed against the specimen of interest. Usually, scanning force tips are used both to perform the indentation and to image the sample surface indentation. The depth of indentation is measured as a function of force applied. The mechanical properties, including elastic constant, can be derived from such loading and unloading curves. A diamond indenter with a small radius of curvature at tip is generally used. This nano indentation device can be mounted on the scanner head of the AFM in place of cantilever. Or also we can define nano indentation is a type of mechanical indentation testing that is formed on a small. Indentation is one of the most frequent methods for determining a material's mechanical characteristics. Nanoindentation is a method for measuring the hardness, plasticity, and elasticity index of the minute quantities of materials. The principle of nanoindentation is similar to the other indentation hardness testers, in which an indenter is forced into the material being tested, forming an indent. The hardness is taken as the ratio of load and the area of contact between the sample and the indenter. During the test, both the load and the displacement of the indenter are recorded. The load displacement curve is used to calculate the contact area at maximum load. This presents the problem related to the measurement of extremely small contact area. With the help of the nano indenter, one can measure the elastic modulus also. In addition to hardness, the two properties are a measure of resistance offered by the material to elastic and plastic deformation respectively. The use of the atomic force microscope along with the nano indentation helps in the positioning of the tip with accuracy with 2 nanometer as shown in the figure below. This is the indenter, sample, motorized stage, capacity and displacement gauge, spring, magnet, is the coil, schematic diagram of nanoindentation mechanism. Also, you can the schematic diagram of nanoindentation test. This is the indenter, the sample is the load. It associated load depth compliance curve. The curve shows the three segment loading and unloading. Loading and unloading is the hold. In nano indentation, small loads and tips size are used so that the indentation area may measure only a few square micrometers or even nanometers. Due to this, a typical electron microscopy techniques may be utilized to image the indentation, but can be quite cumbersome. This problem is generally overcome by using the high precision geometry, namely the Berkowitz tip, which is a three-sided pyramid geometry. Mechanical properties of the sample are then inferred from load displacement curve as shown flowing diagram. The diagram shows that nano indentation results of the different phase in the zirconium platinum alloy, which indicates that the nanocomposite of amorphous and nanocrystalline phase has much higher hardness in Young's modulus comparison to individual phase. Is the nanocrystalline amorphous low displacement chords for nanocrystalline zirconium platinum alloy. Information that can be obtained from nanoindentation. Measurement of hardness substance. The hardness of the material is calculated by dividing the load and the area after contact, where Pmax is the maximum applied load and A is the projected contact area. Determination of effective modulus. The elastic modulus of the material can be measured using nanoindentation. Effective S over 2 root under pi over A. Initial slope of unloading curve. S equal to dF by dH of force. S one equal displacement. Effective indentation area. Fracture toughness, the critical stress intensity factor, which is the stress intensity factor at which a crack starts to propagate, is equivalent to the fracture toughness of the material. Creep and yield stress, nano indentation can be used to measure creep and yield stress at the nano level. Scratch and wear resistance, nano indentation can be used to characterize the materials, scratch and wear resistance. Film substrate addition, nano indentation can be used to measure film substrate addition. Residual resistance, nano indentation can be used to measure residual stress. Application of nanoindentation, thin films and coatings assess hardness modulus. In material science and engineering, the term modulus refers to a measure of the material stiffness or resistance to deformation when subjected to stress. So, thin film and coating assess the hardness modulus and adhesion. Polymers and biomaterials evaluate viscoelastic and creep behavior. Viscoelasticity refers to the property of material that exhibit both elastic and viscous behavior when subjected to deformation. Metals and ceramics analyze hardness, toughness, and residual stress. Residual stress refers to the stress that remains inside a material after the external force or load causing it have been removed. Nanomaterials measures mechanical properties at the nanoscale, composite study heterogeneity and interface properties. Okay, it's all about nano indentation. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. Let us now bye bye. See you again.